Okay, so I like antagonistic and provocative hyperbolic titles to presentations. So, but I do think there has been a problem, and so this is why I want to talk about it. Now, if any of you want to leave right away because you get the idea, this is what I'm going to say by the time I'm done. You line up the automation with the product telemetry and you can do cool stuff. So if you go, oh, I get that, go ahead and go to something else. But the rest of the presentation will be about this. Okay, so since I am going to say, is your automation any good as a question, I am going to take the speaker's conceit of defining good, right? If I was to talk about a different topic, I'd use a different definition. I'll also take that conceit. But for sake of this conversation, a test is good when it helps us discover issues that we understand. Now, little dots there, let's qualify issues. Important to us, important to the business. Understand. We understand their importance. We understand what kinds of issues they are, how we got to them, and things like that. When I say issues, I'm talking in a very, very broad sense of the term. Anything that gets in the way, that's a problem. You may be talking about does not meet requirements, right? So like very atomic checks or things like that. You may just be talking about broad classes of failure, bugs, or things like that. But this is the way I like to think of the test. Is it doing me any good? Does it do these things? Do I understand what's going on? And am I finding things that I need to find? Okay. And this is going to be the backbone of how the rest of the conversation goes. So here's the problem as I see it that we've been facing. And it's been like this for a long time. There is a huge gap, hence the visual, between tests and customers, right? Your test does something, because someone made it do something, someone built it, someone wrote it, and finds things, it has failures or it returns passing results and stuff. And you go and you try to think about what to do, but what you don't know is if it has anything to do with the customer themselves. We try really hard to write tests that matter to the customer, right? The results match something that the customer would like to see as results. And we use processes to look at business requirements and write tests that match those. But there's still a gap, right? It happens before the fact. Someone just builds it, goes into a pile, maybe sits around for a year, 2, 20, who knows, and people lose track. What's it doing? How's it going? You try to use techniques to make it easier to understand, different kinds of reporting and logging stuff, but still, is it really doing something that matters to the customer? Okay? Because the customer is a human being. They're just doing things they want to do or need to do, okay, and acting on their own motives. Well, any modern product that's out there has had to confront the issue of understanding the customer in depth. So we add product telemetry, as Penny mentioned earlier. And this is a constant data stream coming from the product as the customer uses it that says what they're doing. Okay? And any modern company is spending a lot of time and energy thinking, analyzing, looking at what the customer does to understand trends. What kinds of processes are difficult for the customer to do? What do they do the most? Which groups of customers do what kinds of things? Which customers are abandoning our product for other products, and how can you correlate activity to that sort of thing? What sorts of failures seem to matter to the customer, and such as that? We've been doing a lot of this in more of the requirements phase or in more of the sort of business analysis phase. And really, you're seeing a lot of companies, a lot of teams, a lot of products building a very thoroughly sophisticated view of the customer. So, what I think we ought to do is bring the tests closer to the customer. Okay? And it's with a relatively simple trick. Okay? First off, make sure that the tests are emitting the same telemetry through the same system and the same mechanisms that customer usage does. Okay? Which sounds like a natural, well, of course it is. It's the same product. It's sometimes really easy, sometimes really hard. Maybe depend on some history in your company. But the other thing is make the product actually aware of when it's being tested. And the purpose for this is so that you can look at the telemetry signal and go, that one came from a test, that one came from a human user. Okay? And then add some more whatever is test relevant to you into it, so you not just say this came from a test, but which test, for what purpose. Okay? Doing what process. What this does brings the test and the customers closer together. And I assert that now we have two types of users. They're both users. I'm defining user, again, I'm defining my terms, it's the speaker's conceit. A user is an entity that emits a telemetry signal that you analyze. Okay, which, I don't know, maybe I'm the first person that came up with that goofy idea, but it allows me to put them together in the same box and look at them the same way. Now, they're not completely the same, right? And there's a couple of very important differences between these two types of users. One synthetic, the other biological. Tests are controlled. You can make them do anything you want. Run them as many times as you want. They don't get tired. They don't complain. They'll do whatever you tell them to do over and over again. But you don't know how important the activity is, right? I mean, you think it's important, but you're not sure. It's only there because you wrote it, right? And is it realistic? Is the test doing something crazy that nobody down here? Yeah, good. Too abusive on their ears. Can you hear? Right under there. Right under there. Okay. Is that better? Can you guys hear? All the way in the back. Okay, great. Okay, cool. Is the test doing something goofy? Is the test off doing things that no user would ever do or invoking a condition that never matters? Okay, this is a constant problem that people have with tests when they look at them. And you ever had situations where you file a bug that came from the test and the developer comes back at you and says, that's stupid, that'd never happen. And then it's a big argument between you and the developer. Customers, humans, you have no control. They can do anything they want. You can't make them do or not do anything, right? They're unpredictable. But you can assess the priority. You can measure how often they do things. You can measure how often activities correlate to business goals and such as that, because you can just look at the telemetry and start to align things. Furthermore, everything they do is real. You can't say it would never happen if a customer actually did it, right? It's just empirically, by definition, real and true. So what you do is you take these two different types of users and you use their attributes to offset each other, to complement each other, okay? So you take the synthetic users, the test, and you use them to control the uncontrollable, right? The thing that, oh, dang, I need to see this happen, and so I want users to do it so I can tell if the bug went away or if the feature's working, but I have to wait 5 days because that's about how often it takes people to get to it. I can get the test to do it, okay, as many times as I want, under whatever conditions I want. Furthermore, with customers, you take what you know about priority and realism and use it to calibrate the test behaviors. Right? The tests are emitting telemetry now, so now you can look at it and say, well, what did the test emit? Where does that stand in terms of user activity? How often? How important relating to business problems and such? And now suddenly you've got this little cross-check back and forth. You can be using the tests to do something that the users won't do under your command, and you can use the users to know, is the test, and this is where I hook it together, any good? Right? To me, this idea of calling them two types of users felt, oh my God, revolutionary, mind-blowing. But actually, when you look at the slide, it's really hard not to look at the slide and go, well, of course. Whoever would do anything different. But in fact, I feel like we've been going through decades of this without doing this. Right? I just think that the technology with telemetry and investments and analysis stuff have made this really feasible. And now it seems obvious. Okay, that slide's for me. So there's several examples that will follow here. And the deal is I did this to Microsoft Office. So Microsoft Office knows when it's being tested, emits a telemetry signal that says, I'm being tested, and that all gets collected in the same pipe as everything else. And so here's some cases where we're actually using this data. This is a dashboard that was built by an engineering manager on the Word team back when I first did this as an experiment, and he found the data and said, oh God, I need that. So the issue is, inside of Office, when we get a new build, we release it through various rings of users progressively. We go to the Office team at large, then we go to all of Microsoft, and then we go to a select group of external users who said, yeah, sure, we'll take pre-release software, and then we go to the full market, right? And it takes several weeks to get through that, and we do that, a full release to market once a month, but much longer than that to get through this. And the idea is that each group of users uses the product, and we watch and we see the failure signal, and then we decide, do we have to fix something before we go to the next ring? The problem is that especially on the inner rings, they take a long time to use the product. It takes us 2 to 3 weeks of product team usage of the product before we trust the signal to believe we've seen enough failures, right? And we want to make a decision much faster than that. So what the engineering manager here did is he went and dug up the automation signal, found all the activities, and everything that's on here corresponds roughly to a user having clicked something or selected a command or done some sort of feature level activities, and said, okay, I am going to sum together the end users using the product and the automation. So that if we had activities or features where the end users weren't hitting it because, I don't know, maybe it's a seasonal feature, maybe it's something that you don't see people inside our organization using a lot, the automation will cover it. And this bolsters his confidence in the failure signal. Right? Allows us to speed up time to delivery, which is actually a critical business objective. This one real fast. This is a UI on our automation system. It's the page that you go to when a test failed. This test failed, take a look at the failure information. And what I'm showing here is a tab that I added that goes into the telemetry system and says, when this test was running, what were the events that happened? What did the product actually do in order? And so now when you can say, okay, up to the point of failure, what was the product doing at that point? Okay. Meant to help engineers both understand the test better, but also diagnose the analysis. Okay, this is, if I would do 2-3 presentations on this topic, it's one I fixate on, which is variance in product behavior and test results. An interesting question to ask is like, if I take the same test and run it over hundreds of times, how much variance do you see in the product behavior? A lot of people focus on variance in test results, tests that sometimes pass, sometimes fail. And they say, flaky test, throw it away, flaky test, get rid of it. I assert that a whole bunch of variance is actually coming from the product itself. These are tests that really don't do different things every time. They're largely very, 1, 2, 3, 4, 5 kind of things. But as you repeat the test, I noticed this pattern where I would collect the names of the activities, events that were recorded in the telemetry, and then you just sort them alphabetically and get, a single instance of them. So how many distinct names occurred, and I create that sorted alphabetical list as a footprint of that test during that instance. Run it multiple times and see how many footprints I get for a single test, right? And what I found is that as you executed it more and more and more, you got more distinct footprints, right? The product was doing different things every time it ran until it sort of leveled out to about 20 to 30 distinct footprints per test as you repeat it. In other words, variance at the product level is not an exceptional case. It is actually the rule. Okay? The more you run the test, the more the product will do different things up to a certain rate where it flattens out. This is an important factor, I think, that I have yet to really grasp what it implies. But it suggests something about determinism and repeatability when you're running tests in an end-to-end scenario. Modern apps are not deterministic in their behavior as you execute them multiple times. And the data, at least for Microsoft Office, shows this out to be solid. So this is another fun one. So we can see which crashes are occurring in the public. We can see which crashes are happening during our automation. The crashes have an ID that says, oh, this is the same crash as others that occurred in the same place. And so we can track and say, okay, if we saw a crash in automation, did that same crash occur in the public, right? And I broke it down by what kind of test it was, which one of our suites found it. Now, the interesting thing about this list, up at the top, the test suites are no bar. Any old test, not held to any reliability bar, no process. Someone runs it, looks at the results, decides to do with something or not. Down at the bottom, high bar, high process. The tests have to, if run multiple times, yield the same results at a high rate, like 99% plus. And if there's a bug, it's automatically filed by the automation system. Breaks are pulled on production, builds are rejected, and zones locked for changes and stuff. So really, really strict, really, really loose. The deal is that if it's a really, really strict suite with a really strict process, the escape rate of a crash goes down quite low. We stop 82% of the crashes that we find from getting any further. However, they suck for finding crashes. Okay, and I picked crashes because it's hard to argue about the value of crash, right? Other kinds of failures, people go, well, was the test being, picky or something? But a crash is the app going down, okay? But these ones that are really tight, finding low single-digit crashes over a very large span. This is like a 4-month span, okay? As you go up to the top, you're getting 1 and 2 order of magnitude discovery rate of crashes, but a substantially lower stop rate, a higher escape rate. So the suites that are more loose, less regulated, less cleaned up to be reliable every time, do a much better job going into the places of the product that crash. Okay, but perhaps because of the lack of process, perhaps because the suites are less reliable, like if you run it again, you don't see the crash, the engineer is less likely to fix the bug. I also think this speaks enormous amounts about how we look at test suites and engineering processes and things. It's like the higher discovery capabilities are also the hardest ones to manage. And the ones that are easier to manage start to limit themselves in discovery. This is several years ago, one of my cohorts came in and gave a talk about code coverage-based test selection. The same system is actually capable of doing something similar, just at a less granular level. I have an activity, I can just go query and say, well, which test hit it? And you get a list. Then an engineer could say, well, I know I'm changing around this, I can build a test suite based on a test that I see. We can compare the human activity to the test activity and say, how well are the tests covering what the people do? So in this case, this is like a day or two of people using Office in the wild. And we've got, these are the in-market users, the slice of people taking external drops, all of Microsoft, the Office team. And this is the automation, and this is developers at their desktop. And so what we're seeing is that humans in the wild were hitting about twice as much of the event, of the product feature space as the automation was. Okay. But it's also, we can look at the overlap. Okay. So what degree did those sections overlap? About 1/3 of the events that were captured in that were only seen by human beings. Okay, people, past the product team. Another third was seen by all three methods, the humans, the tests, the developers. And then the remaining third is divided up between the different kinds of methods. So again, you can take a look at both of these slides and ask questions about, well, if we want the tests to be predictive, if we want them to find what the users are, failures are having, we need to increase the coverage, right? And this gives you a very hard, fast analysis of the difference. This one, what you're looking at here is a tool that was built by our data scientists in Office that they have an anomaly detection system that they use where they can go build to build, customer group to customer group, or whatever kind of slice you want, and look at failures of different classes and say, is there any anomaly of a current slice against a 30-day window? So you can say, look, such and such is failing more than it used to, okay? The cool thing about this is that the system was just listening to the telemetry pipeline, and the moment I plugged in the automation to go through the same pipeline and be identified as automation, you have the capability of comparing. You can't really see it here, but this is saying, I want to take a look at the automation results for a given run and look at, we call them dog food, that's the product team using its own product, the dog food audience, and is there any anomalous activity that occurred? That analysis is interesting, but the real point that is important to me is somebody else had built this, didn't have automation in mind at all. They were just trying to provide the engineering team ways to look for bugs that were coming from the users. I toss the automation in the pile, bang, I get it for free. There's millions of dollars that went into the infrastructure here. Zoom, it's all mine, right? Okay, and so now I'm going to step away from examples and future-ish kind of ideas. Okay, this is actually not really a future-ish idea because it's an old idea. I gave a talk in 2010 on a similar kind of technique with server load testing, and I've seen this done before, but think about this. If you know what users do, if you know the most common things that they do, you can build models that describe those activities and then feed it back to a test system that can play through the model. Okay? The cool thing about this is that the test system can constantly be adapting itself to changes that happen in the product or the user behaviors. Or you can tweak the model. You can tweak it to prioritize towards, percentage of likelihood that a user would do this. You could tweak it towards percentage of likelihood it will lead to fail. Whatever, but you can feed back from the telemetry straight into the tests. So now the tests are doing something that came from reality. And this is the crazier one, and actually there's this testing and AI talk that I want to attend today, and I'm wondering if he's going into this. I haven't watched his slides or material. But do we even need to write tests? And this is kind of hyperbolic. So let's lay some things down. So something that you'll see a lot of on YouTube are people that are making genetic algorithms that play video games. The example here is one called Mario that beats Mario just by looking at screen alone and then rewarding itself based on time in game and points. And it learns. It learns how to make Mario jump, go left, right, avoid things and things like that, without being told what those things are, right? But also finding failures, finding things that are bad. There's a recent article about Facebook that has a genetic algorithm that searches out crashes by going through and doing things to the app until it crashes and then modifying it to make it more likely to crash. Likewise, over here is a patent from a guy named Stephen Spady who was in the Office team several years back that was a genetic algorithm that would just exercise Office and create what it called DNA streams of things that would make it do things. And if it found a crash and had another one found a crash, it would mutate them together to make a unique string sequence and then go off and try to make that crash. So these are techniques that are currently being investigated, been around for a bit. The idea is the computer seeking out failure, okay? And then here's the why do we need to write tests. So on both of these, we needed to write tests because you had to tell the computer how to do the thing, right? Except for the Mario, that's like discovering how to do the thing. But is it feasible to make the computer figure out how to do the test itself without writing the underlying libraries? And that's actually a popular area in research right now. Over there is an example of a GUI test driver that purely looks at the screen and drives the app. It knows how to click, it knows how to do things, and it watches state change inside the GUI. And if the state changes, it concludes that action was relevant. And it starts building up atomic sequences of actions, slamming them together, and then goal seeking for different kinds of things. In this particular example, I believe it's the one where they were comparing coverage achieved through this methodology versus just a random traversal. And they were able to demonstrate they could get more out of it that way. So the question is like, how far can you push this, right? If you've got telemetry coming back from the product that says, hey, this makes things crash, happens a lot, whatever, you can use those as the reward function, right? Find more crashes, get more coverage, get more complex path coverage, whatever, and loop it in. I think this will be an interesting area that's going to see innovation over the next several years, which will be made more powerful by telemetry. And one more, this is my last future thought thing. I hate the fights that we get into. Should we fix bugs or should we add new features? How many times have you raised, you complain about that, right? And I hate that argument. Should we beef up the test suite and improve it and make it better, or should we do something else? And the reason I hate it is it's just people's opinions, right? And you're just going to beat heads together based on what religion you have until we tie it to a business problem. Okay, so I'm using one example of a business problem, a way to model your business situation, and that is thinking about the acquisition and engagement model with your customers, right? You can think of it like a funnel. It's all about getting people into the product with the initial look, the initial try, and then keeping them around long enough to either get a license or renew a license, or upset them and they abort. Okay, and it's a model that actually gets a lot of analysis in a lot of companies. There's people looking at how many people are leaving, how many people are sticking around and stuff. With the telemetry, these same groups are getting very good at tying this funnel to usage behaviors. If a person used this feature, they are more likely to re-engage. If a person had this experience, they're more likely to abort. My assertion is that you need to start looking through this data for what we think of as the quality level things, errors, bad performance, crashes and things, and say which ones correlate to the business problem. I'll give you an example of crashes that we've decided, or some people have decided don't matter. There's a lot of crashes that will happen in an app before you ever see the app. Right? You double click, the app crashes before you get a splash screen, before the thing comes up and things like that. happens in various apps. As far as we know, nobody cares because they don't know it crashed. Okay? They just think, oh, I clicked wrong. And they click again and the app launches. Okay? Very different than if it were to crash during license renewal. Right? This is the money event. You're at the till. They're ready to say, yes, I want this product. That's it. And you abort, you crash, you dump. Okay? You can actually correlate failures in the licensee sequence with abort. There's a bump in the abort rate. At least the data scientist that I talked to about this was saying, yeah, he had it across the apps. So what should we do with stuff like this? We should pull this kind of intimate knowledge about the product, about the behaviors of the product and usage, into the engineering team so that the quality engineers, the testers, developers are talking about this top ahead. They know the relationships, they know the business, and they know why they're going to either let a pile of bugs sit because they're really not moving the numbers, or invest in fixing them because they know they have to rescue some people from aborting or move them through the process, or add some feature because they know it's the one your competitor is kicking you on. Okay? So, and hopefully if we do something like that, we can start to shave away cases where we're having this argument. And that did I just take you back to the front slide. So that's a presentation. Hopefully you have some approach now in your mind for telling if automation's any good, and questions, comments, jokes. I'll take Matt and then you.
So with your telemetry, is it designed so that it means some of it is very closely bound to user events, like that button or enters this data and scroll this thing, so that you can see clearly, you know, if there's some part that is undercovered with your automation, oh, I have to find a maybe do this, and act more like my customer.
Yeah, so the question was whether the telemetry was closely tied to end user activities, right? Clicking, scrolling, whatsoever. And the answer is some of it, yes, some of it much more than that. Okay, so almost all of the commands inside of the application, you know, if you click a button, if you scroll or whatever, will record a telemetry event. But there's also a bunch more that we collect, which are just, if a developer decided, I'm going to collect this information, it goes in as well. There's a bunch of stuff we don't collect for legal reasons. Okay, we can't identify who you are. We don't collect your content, right? Because there's legal reasons behind that. You get in big trouble in the EU if you do that kind of thing. So, and yeah, once you do that, then you can start to say, you know, can we model? I've seen groups do that. One of the teams inside of Office built a Markov chain description of their feature set and then drove tests that way. So it's been done. And back there. Yeah. Question is, where do you draw the line between telemetry and tracing, right? And I'm assuming by tracing you mean like very, very in-depth developer sort of message things like this got deallocated, this got deref, the thing's value is this. I think that's a philosophical question that you sort of have to get a feel for. I think you wind up with tracing as much more granular information where you'd assume the person who's looking at it is probably the developer, maybe interactively running the product with a debugger attached. Telemetry comes at a cost. Okay, it slows the product down a little bit, and you have to store it somewhere, and the storage is not cheap. Okay, and actually one of the things that Office has been doing is it collected a whole bunch of telemetry, said, "Oh, awesome," and then crunched it, and then turned in and got the first bill. Right, and so then from top down, the team in charge of it said, figure out how to shrink what you're collecting. So there's a lot of strategies once we realized how much we were paying, you know, to keep and process that telemetry. So that plus the thinking about it, plus privacy kind of issues, force you to kind of pick your own guideline on where you're going to draw it. I think the closer you attach it to a user activity, this is someone making a choice, and important forks in the road probably is the right sweet spot. You know, it doesn't go down to the level of like block by block by block stuff that you see with code coverage, right? And tracing is somewhere in between the two, right? So, other questions, comments? Yes. Okay. Okay. So he pointed out that with the system that he works on, there's trace signals all throughout the software that can be turned on and turned off. And the customer, if they're having a problem, has the option to turn on tracing to get more information, send it back to the product team. And so they interpret, I'm putting words in your mouth, I think, if the customer turned on the tracing, they mustn't have been happy, right? Because they're trying to send you more information, which that's an interesting way to look at it. You'd see that kind of thing happening. Where? You're pointing at someone. Oh, yes, over there. Sure. So the question is let's say that your company, your team, your product is not collecting data, period, or enough. Yeah. What's the approach? God, I wasn't the one that convinced the office to start collecting telemetry, so I didn't get to watch the rhetoric there. One of the key things is that the competitors are all doing it. So the competitors have an edge. They can know something you can't. And really, if you don't have the telemetry in place, you're talking about learning things on the order of months, years, where a competitor knows it minutes. Okay? So that's actually probably the biggest reason why you want to get something in there. You know, you can release something and you can know minutes after it hits whatever channel it is if you did something wrong. And if you need to maybe turn something off or stop something. Versus we send it out, ship it, and God, we don't really know what's going on for maybe 3 months, 6 months, or things like that. And that really is, in my experience, that is the world difference that we're in now. It used to be with Office. You know, you'd ship it to millions of people, but really most enterprises take 6 months to a year to do a major software rollout. And that's when you actually find out the issues you have to fix that would come in the next service pack. Right? So Service Pack 1 was always kind of like, yeah, there's some stuff. But it was Service Pack 2 that actually meant something, because that's how long it took the bulk of the customers who actually had a channel back to tell us what was wrong so we could fix it. It's not like that anymore. Right? I know product teams who are like, they're saying, okay, the thing dropped yesterday. What are we seeing? And they're in a meeting, they're saying, this came up, this came up, this came up. Who's looking at it? Who's looking at it? Get it fixed. Can we do that now? Can we turn off a feature now and make the problem go away? It really is, even with Office, the desktop app, come down to a situation where product teams can tell right away if something's wrong and start applying mitigating fixes if the mechanism's available. So. Yeah, that's a good question. So is the desktop versus 365 the web app or service? Yeah. So I got two questions from you there. Right. So the first was, is this the desktop app or the cloud-based apps? And the second was if we're seeing patterns. So all of the data that you saw here was from the desktop client. The cloud guys collect telemetry in depth too. They're ahead of the client in that because it's easier to do on a cloud-based application. It's also easier to respond. Okay. But everything you saw here was actually changes I made to the desktop app to get it wired into our telemetry system. The other question is, are we seeing different patterns between users that want to, are willing to go cloud versus want to stick with desktop versus other kinds of thing? And I'm going to say yes, but I'm not adept at all those, like what defines those differences. There are most certainly people who are reluctant to go into a cloud-based version of Office. They want to stick to desktop only. There's others that jump all the way into the cloud. They're tired of, whatever limitations they had otherwise. Especially with the enterprise customers, you see less excitement about fast release patterns. That's actually something that you see. As a company, you want to say, we can fix you anytime we want. If you've got a problem, we can get you out there, so long as the mechanism is non-disruptive. But enterprise customers don't like getting something that frequent. They like to control what they're getting. It has impacts on their help desk. It has impacts on their tools. If there's new issues, they want to retrain people. And so there's several categories of customers that have different preferences and between cloud, desktop, perpetual license, fast updates. I'm not articulated in all of them. I think you'd have to talk to someone else who's been eyeballs on that data to get. So the answer is yes, but I don't know at all. Yes? Okay. Yeah. So the question is how are we taking the telemetry data and tying it back to the automation? Does it go to scenario level, or does it go all the way back to the unit test? And the answer is almost entirely scenario level. And by scenario, I mean the end-to-end tests that run the whole app. And the reason for that is actually technical. The telemetry system is part of Office. It's part of the core DLLs that's in Office. And when you're doing a unit test, you're only loading the one DLL into memory that you're testing, right? It's technically so if the DLL that has the telemetry stuff in it is in a separate DLL from what's under test, it's not going to get invoked. It's not going to do anything, right? And furthermore, that system has a bunch of dependencies that have to load up. So if someone has written a true unit test, right, down at the class or method level or something like that, the telemetry doesn't get recorded just as a technical thing. With regard to the rest of our automation, all of our end-to-end tests, they all exist in a large test automation system that has a database. It has an ID for every test that references all the things that get loaded. And that's what it's joining back to. When we record the telemetry, we send an event that's called an automation metadata event. And it has the test ID, the job ID, which is the job that was running, the specific task that ran the test, and what configuration it was under, and things like that. So that's how we join back, because we know that ID, and that corresponds to something in our database. So, other questions? Okay. So the question, I'm going to try to get this right, is that there's a lot of, you alluded to a lot of material regarding functional points and metrics regarding quality and error rates of functional points. And the question is that, does that tie into this telemetry information, right? And I'm going to say I actually don't know, because the first part, I'm not as familiar with functional point metrics and failure and stuff and exactly what's being talked about there. My point with the telemetry stuff is that this is an empirical sampling of actual usage, okay? So long as you can take whatever it is you're talking about and say, I can tie that to something, then you should be able to start to draw correlations, right? And so I don't know if what you're talking about is like more of a business planning construct, or if it's actually say, yeah, I'm looking at from empirical evidence in the product under usage or not. But I would think that it's at some point it's just a mapping, I'd assume, but I don't know enough to really answer the question. Other questions? Yes? This one. Oh, yeah, okay. Yes. So yeah, this graph says that all of this stuff are things that the automation and the devs doing their own tests did not hit. It's a gap. It's a coverage gap, and it's a problem. So, the question is like, if you see a gap like this, how do you measure it back? I haven't come up with a mechanism to measure back if you've improved it or not, but I assume it's got to be doable. But it's funny because I was working with an engineer in one of the product teams where I showed him how to do this analysis, and so what he did was he took the activities that are occurring in production and ordered them by frequency. So the top 25, top 50, top 100, top 500, and then broke them down by distribution to say how far into that depth, because there's like 1,000 to 3,000 activities that app overall emits. How far into that depth does he need to get what percentage of usage? And what he concluded was if you got to the top 100 activities, about like one order of magnitude down from the whole way through, he was about 99% of the actual usage that occurs in production. So he said, okay, I'm going to compare my automation now against the top 100 activities and see where the gap is. And from that, he was actually able to come up with, at the 25th, top 25, there was like 7 points missing. At the 50, there was something like 20-some missing, and on up. And so he started getting into numbers that were started off huge, thousands and thousands of points not touched, to, you know what, you could actually address this. Just take a plan and try to cover it. And furthermore, he found that in our build verification suites, which are really tight and regulated, it was higher than in the really loosey-goosey suite. We actually had some stuff we were covering in the loosey-goosey suite. He said, if we just shore that suite up and move it over, we'd be covering, he got himself halfway there, just through managing what test run, what suites. So that's a way to build a plan, this numbers-driven way of building a plan. And then I would think you just take a snapshot at one stage, change it up, take the snapshot again, and see if this ratio closes. Especially if you start tempering on, I'm only going to look at the top n out of these, then I think these numbers would move a bit. Where are we at? We're at 1 minute? Okay. That's it. Thank you.